Hi everyone, it's a pleasure to be speaking to you all today at the conference. So we've got a bit of time today to talk about genetics and cardiomyopathy, and as Alison said, please do think of any questions. No question is too simple or too complicated. Well, it might be too complicated for me, but let's see. But we'll have a chat at the end about that as well. But I thought I'd give you just a bit of an outline really of who I am, what I do, and how that interacts with cardiomyopathy as a condition. And we'll do a bit of a background on genetics as well. Okay, so Alison mentioned that I'm under Guy's and St Thomas's NHS Trust, but we all know how complicated the NHS is. So actually, I'm under that trust, but I work at the Brompton and Harefield hospitals at the moment. But yes, we're sort of part of that. So we see lots of different patients with various different inherited heart conditions, but cardiomyopathy is one of the main conditions that we see. So today, I thought we'd start with fundamentals of genetics, so a bit of a starter on genetics and what it involves and why it's important for heart conditions and why it's important to understand the causes of them. So zoning in a bit on the genetic causes of cardiomyopathy itself. Talk a bit more about the practicalities of genetic testing and the different types of genetic testing we can do. A bit more of an explainer on who I am and what I do and some of the things that I might cover in an appointment with a patient. Zoning in a bit on family planning and some of the options that are there, because I know there's always a lot of interest into that and it can sound a bit sci-fi, so just kind of deciphering that a bit as well. And the all-important question that I often get asked by patients, and I was asked it quite a lot last time I came to the cardiomyopathy conference, was about accessing genetic testing, because I think historically there have been issues with that in the past, and hopefully we're on a path to better access in the future. We can talk about that as well. So let's start with some fundamentals of genetics. So I've got this nice graphic up here borrowed from Genetic Alliance UK, the organisation. And we can see on the right, the big yellow circle is a human cell. And the blue circle in the middle is what we call the nucleus of the cell. So that contains all of our genetic material, or nearly all of our genetic material. And if we zoom in on that nucleus, we can see the little green and pink sticks, which are our chromosomes. And they are essentially bundles of genetic material, our DNA. Oops, didn't mean to zoom in then. There we go. So DNA we can think of as the blueprint for building the human body. Okay, so it's got all the fundamental instructions we need to build all of our organs and make sure they function properly. And if we stretched out that chromosome, we're pulling out a strand of DNA. So that's that long string that actually looks like a double helix if we look at it at the bottom of the graphic. And that DNA is sectioned up in what we call genes. And these genes, most of them are instructions for building a specific protein in the body. So we call these protein coding genes. So we've got about 20,000 of these protein coding genes in our body. And there is also other DNA as well that has other regulatory functions in the body as well. So nearly all of our genes come in pairs. So we get one from our mum and one from our dad. And as we said before, all of this genetic material, if we stretched it out, it would go, I think it goes to the moon or something, or around the whole world. It's long. So we've got to bundle it up really tightly and package it so it fits into our cells. And that's what the chromosomes are. They're little bundles of DNA that keep all of our genetic material. And again, they come in pairs. So we've got 23 pairs of chromosomes, and we've got one chromosome from each parent usually. Okay, so you might have heard this fun fact about a banana. So we're not so dissimilar from a banana. We share about 40% of our DNA with them. As we move up the food chain, we become more and more similar. So 61% of our DNA is shared with fruit flies, and 85% of our DNA is shared with a mouse. And historically, we've been using things like fruit flies and mice to understand genetics better because we can do scientific studies on them. And some of the fundamental principles of genetics were found out from doing studies on animals and understanding the modes of inheritance and how things are passed on. But how similar are we within humans? So we actually share 99.9% of our DNA with the person sitting next to us. So we're all pretty much identical, except for that 0.1% that's different. And that's what makes us unique. And most of that variation is healthy. So it's just the thing that might mean you have blue eyes, green eyes, curly hair, straight hair, tall, short. We're thinking about that very, very small percentage of variation that causes disease. And that's what I look at as a genetic counsellor. So just to get into a bit more of the nitty-gritty, and this is a bit scientific, so let's see how we go. When we're doing a genetic test, we're trying to see what changes exist in the DNA and what effect do they have on our bodies. How do they affect the proteins that build our bodies, build our organs, and function within the body? So you'll see all these jargony genetics words on the left, and this is what we use to describe variation and changes within the DNA and the effect that has on the proteins in our body. So you see this picture here. At the top, there's a string of letters, and that's the letters that make up our genetic code. And those letters are coding for a protein. So the protein is described at the bottom. It's built up of amino acids, so they're the building blocks of the protein. And if we look below, on the line below, you can see that one of the letters in that sequence has changed. So it used to be a G, and now it's an A. And that has caused the protein to change. So a single amino acid, a single building block in that protein has changed. And that could completely wipe that protein out and stop it from working properly. And that could cause disease. Or the protein could still work completely well, but we need to use science to understand, is this particular genetic variation causing problems in the body? And this particular type of genetic variation, if you want to get really nitty-gritty, we call this a missense change, because it's just describing that this change in the code causes a change at the protein level and changes one amino acid. Okay, so this is the sort of thing that the lab is doing for me when I send off the blood and they're doing a genetic test. They're looking for these changes and think, are these causing problems? Could these explain someone's condition that they have? And luckily the lab do that for me. People think that I'm doing the testing, but I'm not. I'm just getting the reports. I get all the glory. But interpreting that report can also be a challenge. So when we get the reports, the lab have been doing all the work in the background in what we call classifying the variation that they've seen in the genome. So as I said, most of the variation we have is healthy, and the scientific word for that is benign. So it's just a part, it's a unique part or a different part of your genetic makeup, but it's not causing you any problems as far as we know. And if there's a change in the DNA that's causing problems, that's causing disease, it's affecting the protein's not working properly, we call that disease-causing or pathogenic. So you might have even seen that if you've had genetic testing, they'll say, oh, you've got a pathogenic variant in this gene. And that just means that this gene is causing your disease. And one of the challenges in genetic counselling is we're often stuck in the middle. So that yellow section there of uncertainty. So we might find a change in one of the genes, but we don't know if that's actually causing disease or if it's just a normal, healthy part of genetic makeup. And in genetics, we call that a variant of unknown significance. And that's really difficult because we've found something, but does it mean anything? We don't know. And it's really hard to explain that to patients as well, because they say, oh, they found the gene, but have we actually found it? Or are we completely barking up the wrong tree here? And this is just a healthy part of someone's genetic makeup. So a lot of the work that we do as a genetic counsellor is to try and better understand these uncertain results, do more research, do more digging, try and find other families who might have similar genetic results, bring all that information together and hopefully end that uncertainty and be able to say this is pathogenic or this is benign. But unfortunately, we are stuck in the grey zone a lot of the time. So, thinking about cardiomyopathy specifically. So I've got kind of a scientific-looking image on the right-hand side. This is what scientists have said that the protein myosin heavy chain looks like. So they have these amazing computer modelling systems that can model what a protein should look like in the body and its structure. So I thought I'd draw in on a particular gene that causes cardiomyopathy as an example. So we know that there are lots of different genes that can cause cardiomyopathy. And when we do a genetic test, we throw our net wide. So we do what we call a panel test, which means we look at a number of different genes that we know can cause the condition. Most of those genes are genes that are involved in building the heart muscle. So they code for those proteins that are part of our heart muscle. And if we have a problem with one of those genes, the heart muscle isn't built quite correctly, and that can cause cardiomyopathy to develop. So this is an example gene. This is one of the most common genes that can cause cardiomyopathy. They've all got kind of code names. So this one's MYH7. And because I've been in this job for many years now, I know these all off the tip of my tongue, but it just sounds like we're all talking gibberish if you were just going to walk in one of our meetings, because everything's got a different code name. But yeah, this particular gene, as I said, it codes for a protein, and that protein is called myosin heavy chain, which plays a really important part of building the heart muscle. And if we have a change within that gene, a variant within that gene that stops it from working properly, it can cause cardiomyopathy. The interesting thing about this gene is different variants can cause different types of cardiomyopathy. So if you have a certain type of variant, it can cause hypertrophic cardiomyopathy, and then another type of variant might cause dilated cardiomyopathy. But it's all the same gene, it's just different changes within that gene that can affect it in different ways and cause different diseases in the body. So let's talk about how this condition is inherited. So I'm talking generally here about cardiomyopathy because there are a small number of families where the condition is inherited in a different way. But for the vast majority of families, it's a dominant condition. And I'll explain what that means in a moment. And I've put some more of my genetic jargon words here. So we've got incomplete penetrance and variable expressivity, which I will also explain. So if we have a pair of genes here, imagine this is an MYH7 gene, the one we just spoke about. This is a person who's been diagnosed with hypertrophic cardiomyopathy. We've done a genetic test, and you can see the cross through the left-hand side circle is showing that that gene is not working properly. So when that person has children, we expect there's a 50-50 chance of passing on that faulty gene. Okay. And the fact that just having one faulty gene and a working copy of the gene is enough for you to have the condition, we call that dominant inheritance. So that gene is essentially dominant over the working copy. Even though we've got that working copy there, the faulty one is going to cause problems in the body. Okay. However, one of the things that makes the inheritance of cardiomyopathy quite complicated and can make it hard to interpret the history in the family is that some people will have the faulty gene and will scan their heart and it looks completely normal. And that's what we call incomplete penetrance. So you have the faulty gene, but at the stage of life you're having that scan, the heart looks normal. It may be that we come back in a few years' time and something's developed. It may be you get to the age of 70, 80 and everything's still normal. So what we tend to see in families is some people will have the gene and be affected and other people won't. We don't fully understand why that happens. We think it's probably a combination of effects of the environment and other genetic factors as well, so other genes interacting that can sort of bring on the condition or maybe be protective factors against the condition. And the third point, this variable expressivity, is another thing that we tend to see in families with cardiomyopathy. Some people might have the condition severely, some people might have it really mildly, some people might develop it when they're young, some people might develop it when they're older. So even though it's the same exact faulty gene being passed through the family, it affects people differently. And again, we think that's a combination of environmental and genetic factors that can cause that. So coming back to the inheritance pattern, so this person who has hypertrophic cardiomyopathy wants to have children. So when they have children, their partner will pass on an MYH7 gene that's working fine, but they will either pass on the faulty copy or the working copy, and that's where that 50-50 chance comes from. And it really is a 50-50. It's a flip of a coin each time, and it's not linked to gender at all. It's just a 50-50, boys and girls. Okay, so that brings us to a type of testing that I often have discussions about with families. So, for example, if someone has a parent with cardiomyopathy and they have a known genetic variant that's causing the condition for them, they may have the option of having a genetic test to see if they've inherited that variant. And they may have completely normal heart scans. So this genetic test is going to show if they've inherited the variant, and if they have, that they need to continue having heart scans because we will consider them to have an increased chance of developing cardiomyopathy in the future. And so we call this a predictive genetic test because it's predicting someone's chances of developing the condition. So one of my main jobs as a genetic counsellor is to meet with people and explain what this test entails, what the possible results are, and explore what that might mean for them if this is a test that they want to do at this point in their lives. So particularly for young people, it can be a hard decision to make. Do you want to know that you may develop this heart condition? That could be in 10 years' time, could be in 20 years' time, could never happen. Do you want to be labelled with that at the age of 15, 16, 17? You might be in the middle of your exams, you might have a lot going on in your life. How would you feel if we came back with that result? So it's not a compulsory test, but it's an option that is available to some people in families. And it's my job to sort of talk people through that and help them make that decision going forward. And something I always like to highlight when I'm doing talks about genetic testing is a common bit of misinformation. So people tell me, I'm not going to have a genetic test because I won't be able to get life insurance. And actually, with this type of predictive genetic testing, it shouldn't have any implications for your life insurance. If you don't have cardiomyopathy, but you have the genetic variant in the family, you don't have to give that information to an insurance company. There's a very special agreement that they've come to that they're not allowed to ask that information. So it's a different case if you have cardiomyopathy, and probably some of you experience that in terms of getting insurance, that it's hard and expensive if you can get it at all. But with predictive genetic testing, this type of test should not have an impact. And if you get a good news result, so if we show that you haven't inherited the genetic variant, although you don't have to tell an insurance company, you can tell them. So you can say, look, I've got this history of heart conditions in my family, but I'm not at risk of it. So it can work in your favour, but they can't use it against you at this point in time. And that agreement that we have with insurance companies is ongoing. So there's no end date for that at the moment. So I always like to tell people because there's a lot of fear around genetics and insurance and things like that. So just to explain a bit more about me, I guess you've got a bit of background already, but genetic counsellors are a bit of a rare breed in the NHS. So there's about 300 of us working in the UK, but it is an international profession. So there's people all over the world doing genetic counselling, and it's a real focus of the NHS right now to roll out genetic services throughout the UK and make genetic testing more accessible to people. So I think there will be more genetic counsellors in the future. We're not doctors, so we can't diagnose, but we're trained in counselling. So we have basic counselling skills and also trained in genetics as well. So it used to be like a master's programme that was done, and now it's an on-the-job training programme that's done as part of the NHS. And so the genetic counsellor traditionally was based within a genetic service, and patients would be referred to them for a discussion. But now there's a lot more people like myself being based within specialties. So I'm based in cardiology. So I'm there to work within the team. So I work with the nurses, the doctors, the lab, and I'm kind of like that liaison between everyone. So, I'll often be meeting with someone and say, we're going to talk about genetic testing, and they'll say, oh, well, I fainted 2 days ago. What should I do about that? And that I'm not trained to interpret that, but I've got close links with the nurses and the doctors, and we can link in and we can manage it going forward. So it really is like a multidisciplinary team approach to doing things. And when I meet with patients, so at the moment, we started in COVID doing a lot of our meetings over video appointment, and we've actually carried that on now because we found that patients, a lot of patients prefer to do video calls. They don't have to come to the hospital just for a chat with me. It can take a lot of time, it's hard with childcare, work, it's expensive. So we tend to talk over video call, and then if patients decide to go ahead with genetic testing, I can get the blood sample sorted out locally, so they can even have it done through the GP and then post it to us. So it's a changing profession. People used to come in and have these long conversations in the hospital, and now it's a bit more of an at-home service for people as well that we can do virtually. And my goal when I have an appointment is I normally take some time to take some information from the patient about their history, their family history, draw out the family tree, interpret any other conditions in the family. Is there anything else in the family that they should be referred to be checked for? I'm mainly focusing on the history of heart conditions, who else has been affected in the family. And once I've done that assessment, we can decide if there's a genetic test we can offer for them, explain the process of that, explain the possible results. If they want to go ahead, we'll get the blood sample sorted. I'll get the results in a few months' time, usually, because it takes a long time. And we'll do another video call when they're back. And if something's found that we need to, there's other family members that need to be tested, I then facilitate getting them checked as well. So you can end up seeing multiple members of the same family, which is one of the really nice parts of my job, getting to know patients, but also the wider family as well, and following them on their journey through their healthcare. It's also important for a genetic counsellor to, although we have basic training in psychology, we're not psychologists. We don't offer ongoing counselling or psychological support. So it's signposting patients to sources of support. So I'm very fortunate to have a psychology service at my hospital that I can refer patients to, but also support in general, like organisations like Cardiomyopathy UK, other patient organisations, other sources of support that sometimes can be difficult to find, and I can point people in the right direction. So often people will have questions for me when they come to the appointment. Barn door appointment is about genetic testing and screening of family members, but people will come as well hoping to have children in the future. So I thought I'd just give you a bit of an overview of that as well, because I think that can sometimes be interesting to hear what's available to people going forward. So in a family planning appointment, I need to, again, take in all that information from the patient about themselves and their family and make an assessment of what options are available to them. So these are some of the options that I could talk about with patients, but they're not applicable to all patients, and different patients will be sort of eligible or suitable for different options. So I always tell patients that natural conception is an option for them. Probably most patients go down that route. But if there is an inherited cardiomyopathy in the family, we'll just need to sort out some checks for their children at the appropriate age. But some people feel that if there's a known genetic cardiomyopathy in the family, they want to prevent passing that on to future generations. So there's a few different options we can explore in terms of that. One of them is Preimplantation Genetic Diagnosis, which is a mouthful, so we shorten it to PGD. I'll talk about that one in a little bit more detail in a moment. Another one is prenatal testing, which is a test during pregnancy. We'll talk a bit more about that one as well. For some patients, we might talk about using a donor. So that could be an egg donor, a sperm donor, an embryo that's donated. And that can be particularly useful for patients if we don't know the genetic cause of their cardiomyopathy. So maybe we're suspicious it is running in the family, but we just haven't been able to find the exact gene that's caused it. So we can't do any of that genetic screening in pregnancy, but they still don't want to pass the condition on, so we can talk about using a donor then. I put surrogacy there because sometimes women with cardiomyopathy have advice from their doctors that it might be dangerous for them to carry a pregnancy. Not all women, but a small number, it might be sort of advised that they don't do that. And so I have had patients who've explored the route of using a surrogate to have a baby. And we talk about adoption and fostering as well as another option for patients. So as I said, I think I'll zoom in on these two because I think there's a bit more we can talk about what they involve and how they work. So preimplantation genetic diagnosis can sound a bit sci-fi, but actually it is, in its essence, very similar to IVF. So it uses the whole process of IVF, which many of you have likely heard of. So the female partner takes medications, hormonal medications to stimulate ovulation, and then under sedation they take a sample of eggs, and they would use a sperm sample from the male partner and create embryos outside of the body. So they used to call it test tube babies. And those embryos are then used to implant into the womb and hopefully will result in a pregnancy. So IVF was traditionally used for couples with problems with conception, fertility issues, but we can do IVF with an extra step now, which is the same process that I've described, but once the embryos are created at an early stage of development, they take a small number of cells and they test those cells to see if they've inherited the genetic variant in the family that's causing cardiomyopathy. And they would only use embryos that haven't inherited the condition. So it's just to prevent passing the condition on after that. It's something that's available on the NHS. So we have centres in London that are doing this now. But it is quite strictly, sort of the eligibility criteria are quite strict. So not everyone will be eligible for funding. So there's lots of things about sort of your age. You've got to be under 39. You have to have a healthy BMI. You can't have already a child that's unaffected with the condition. They will only fund one child on the NHS. So some people choose to, if they don't meet the criteria, privately fund doing PGD, and it is expensive. I think it's over £10,000 to do it. So yeah, it is something that can be done in the NHS. There's obviously waiting lists. It's not an easy procedure at all to go through, but it's an option that's there that I talk to patients about. So moving on to another option that we talk about is prenatal testing. So this is to conceive naturally and then have a test early in pregnancy to see if the fetus has inherited the genetic variant causing cardiomyopathy. So traditionally, this was done with what we call an invasive test. So this is quite a common procedure for women during pregnancy, that they would have either what we call an amniocentesis or chorionic villus sampling, CVS. And it's essentially where they use a needle through the belly to take a sample of either placental tissue or amniotic fluid. And again, that's to see if the fetus has inherited the genetic variant causing cardiomyopathy. So it's done from about 11 to 20 weeks of pregnancy. And if the fetus has inherited the variant, there's the option of ending the pregnancy. So one of the issues with this is there is a risk of miscarriage. So it's a small risk, but it's there. Because you're inserting sort of a foreign body into the belly, there's an infection risk. So it's about just under a 1% risk of miscarriage with this procedure. So obviously that needs to be weighed up. And there's also the thought of ending a pregnancy as well. Some patients choose to go down this route, but not all. But something that's become available on the NHS quite recently is non-invasive testing. So again, it involves getting pregnant naturally, but it's not, we don't have to put a needle into the belly. So when the embryo is developing, the cells from the placenta carry the fetus's DNA, And that DNA, some of it is shed into the mum's blood. So most of the DNA in the mum's blood will be her own, but a small percentage of that will be the DNA from the fetus. And through some amazing scientific method, they're able to take a sample of mum's blood, separate out that DNA, and test to see if the fetus has inherited the genetic variant causing cardiomyopathy. So it means we can do the test earlier, so it's done at 9 weeks pregnancy from then, and it doesn't have that risk of miscarriage because it's just like a normal blood test for mum. Though obviously it still has the thought of ending a pregnancy if the fetus has inherited the genetic variant. So that's something that's recently become available to patients with cardiomyopathy on the NHS. But importantly, it only works if it's the male partner who has the variant, because if the female partner's got it, it's impossible to disentangle the variant from her blood and from the fetus's blood. So it's for when the male partner is affected only. So the all-important question, how do I get a genetic test? I hope people in the audience here who are eligible for genetic testing have been offered it, but I appreciate that that is not always the case, and it seems to be a bit of a postcode lottery in the NHS of who gets access to testing, and it's one of my most commonly asked questions as a genetic counsellor. And this problem has been recognised as a national problem for patients across all different conditions, not just cardiomyopathy. So how have we tried to address this problem? Well, there's one of the biggest areas of investment in the NHS at the moment is genetics, or what they like to term genomics. That's the buzzword, but it's all the same thing. We're just looking at the human genome, and we're doing testing to try and find the cause of diseases. So there's lots of focus on this at the moment in the NHS. There's lots of funding going into it. And there's been a programme where they're trying to set up national access to genetic testing, and they call it mainstreaming genetic testing, that rather than a patient having to get referred into clinical genetics, wait months and months and months for an appointment, it can be requested within the clinical team they're already in. So for yourselves, it would be the cardiology team. So the cardiologist could request the testing. And there's national funding now for this type of testing. And this is all done through what we call the National Genomic Test Directory. This testing does have eligibility criteria. So these have been designed to ensure that the testing is offered to the people that we're most likely to find a genetic cause for their condition. So it's trying to make sure that the resources are sort of properly allocated. So probably not everyone will be eligible for testing. But if there is a high suspicion of a genetic cause for your cardiomyopathy, then you should be eligible for that test through this national programme. And that's why there's sort of a growing need for genetic counsellors based within cardiology to facilitate this, because I think at the moment there are cardiologists and cardiac nurses who are specially trained in genetics, but not all of them. And they don't feel comfortable ordering this testing and interpreting these complicated results. So there's a lot of investment in the NHS to not only upskill those people to better understand genetics and be able to request these tests themselves, but also for people like myself to sort of support that as well and support families going through the testing progress. So I guess I put some suggestions here if you are still struggling to access testing. If your cardiologist isn't happy to request the test for you, if you're referred to your local genetic service, they can do that. Or if you're referred to a specialist inherited cardiac conditions clinic, like where I work, they can do that. So it could be that they could refer you there. I always point people to a really great organisation, Gene People. So it's a national charity that they have a helpline that's run by genetic counsellors. So if you need advice for your local area, where do I go, who should I be referred to, they can support you with that. And obviously, Cardiomyopathy UK, British Heart Foundation, I'm sure they get asked questions like this all the time as well, so they might be able to signpost you. But it is a bit of a maze. The NHS is working hard to try and make it a bit less of a maze and to provide more funding for testing going forward. But yeah, I think it will improve, but it's a bit of a slow progress at the moment. So that's all I was going to cover today. I've given you lots of time for questions and discussion. I put a question for you as my audience. If you feel comfortable answering it, you really don't have to. But I just wondered if any of you had genetic testing for cardiomyopathy, and what was that like for you as a process, and what personally or as part of your family, how has that been for you? But obviously I'm open to any other questions as well, so feel free to ask.
I'm quite happy to answer that question. So we found the gene in the family. My husband has HoCM about 4 years ago. Both the children were tested. They were 18 and 21 at the time, having been screened at GOSH continuously since they were young. And one son has the gene and one son doesn't. And I suppose we didn't think about the impact at the time because it's always been part of our life as the children growing up. But it wasn't until my younger son had a girlfriend. And then it was like, oh, okay, how does that impact and all of that? So it's really great for me to see all of the opportunity that there will be for him. He's not with that girlfriend, can I say? But when he does have another girlfriend, yeah, we've got more answers, so thank you.
I'm sure this wouldn't happen now. I think we were just a bit unfortunate because both my daughters, well, we were very lucky actually because once my husband's gene was identified, both my daughters in their late teens had blood tests, but they didn't want to know what they had. It's interesting about insurance because my eldest actually did get impacted on for house insurance just because she put down that her dad had the condition. They've since said both been tested, and my younger one wanted to find out what the blood result was, and she was told she was positive, but she got the genetic counselling again before she was given the results. My eldest daughter, and I don't know the whole story behind it, but she was already pregnant, and then she decided that she would ask for the blood test that she'd had done previously to get the results. And because it was numbered, but not, that it was sent off, but then a month later they said, we can't accept that one, you've got to have it done again because it's not got your name and everything on. Maybe they knew there was something and they wanted to double check. So then she got a phone call, and I don't know who it's from, I have no idea. But she was in absolute tears because the person that called her, because she'd had this blood test done years ago, I get the feeling she didn't ask or didn't get the full reminder of the impact. And she was already pregnant. So when she got the phone call, the nurse just said, oh, I've got your result and you're positive. And then she burst into tears and she said, well, why are you crying? And she said, well, because I'm pregnant. And then she was told what her options would be. But as a mum, I would never have not wanted to have my kids, even though now they both carry the gene. I would never, ever have not wanted them to be in my life. And her little girl, who's gorgeous, who again has got to be in the screening program, I can't imagine how, the choices that you have must be incredibly difficult because I could not imagine my grandchild not being there and being offered the choice of, because you, as you said, you just don't know how this condition is going to express. So you're making a choice on something that you don't actually know. And it's so complicated, isn't it? It's not easy. It's not straightforward, especially as a lot of mums now are having children later in life, in their 30s, where they may not have, lots and lots of years to... And then you've got other genetic conditions that come in to play because of that. So, yeah, that's just... We had a mixed experience.
Yeah, it sounds like that was really difficult, actually, especially for your daughter. That, I think that's the importance of having that chat before. How would you feel, if you were pregnant and you got this result during your pregnancy? It just gives it that whole another layer of complication, doesn't it? And you're quite right, when I present these options, I present them sort of very scientifically. Here's your options, there you go. But it is such a loaded thing because there's people here who have cardiomyopathy, and they've lived full lives, contributed to society. We don't want to, that whole ethical feeling of, should we prevent this from future generations when it could be something so mild, we could have better treatments for it in the future. And it is a really difficult discussion because we're telling people, if you have a child, they could be completely fine, or they could have the condition quite severely, and we have so much uncertainty. So, yeah, you've really highlighted the sort of nuances of that. So thank you. And yeah, I guess as a genetic counsellor, that's why we always present it as an option, but we never tell people what they should do, because it all depends on them, their own personal experience, and their experience within their family as well.
My son has been tested, and he's come up with these genes of unknown significance. Now, his wife is now pregnant. Should he be pushing for her to test the unborn child?
So that's a really good question. So if it's what we call a variant of unknown significance, we wouldn't test for that because we don't really know what it means. If the child's inherited that, we don't know if that actually would cause them to develop cardiomyopathy, because it could be that's just a normal, healthy part of your son's genetic makeup. So in that instance, we wouldn't do this type of testing in pregnancy. We'd just recommend some scans for his child when they're at the right age. Yeah, good question though.
Hiya. So me and my sister, we both have cardiomyopathy. We were diagnosed within a week of each other. It was a hectic year. We have done genetic testing through Bart's, and they said it was inconclusive. So our parents, they said they didn't know where it's come from. Would you recommend doing the genetic testing again later down the line? Or because we just blame our mum for everything, it's her fault.
I guess it depends on the results of your test. So if it was done a few years ago, I'd definitely check in with them, because we learn more all the time. So even if you come back a year later, they can reevaluate the test and see if they might find another family with the same genetic result as you and be able to reevaluate it. So even if you're in the grey zone now, it may be in the future. But sometimes we have to ask you to check back in with us, because we don't routinely check back on all the families. So I'd say you should do that. Yeah.
Hi, I'm under the inherited at Brompton.
Mm-hmm.
What I have, LVNC, is known to be a geneticy one, geneticy, if that's a word. I've had one call where they went through my details. I missed a call in August because I was stuck in a meeting at work. Now on my next call in February, what are the calls going to do? And then they said, oh, we'll make sure everyone gets an echo. Well, the echo is just a snapshot in time now, isn't it? Mm. When my daughters tried to get an echo, they said, well, we're prioritising people who have symptoms. Thing is, I didn't have symptoms. By the time I was diagnosed, I was severe. So that's a bit of a concern. I don't want her to lie to get an echo. And even if she does get an echo, it's only a snapshot in time. I want the proper genetic. But I'm getting calls, which is lovely to talk to people, but... take my blood, please.
So you haven't been offered a genetic test. LVNC, the non-compaction cardiomyopathy, is notoriously difficult to do genetic testing for.
Okay.
It's the one where we get the least results. So it may be that's why you haven't been offered it, because if we do the test, they may not find anything. We do in a small number of cases, but that might be the reason. But do check it when you have your phone call.
In February,
speak to them and find out if it's something you could be eligible for.
Oh, that's very interesting, because no one's actually said that up to now.
Yeah.
You've asked a question that's answered half of what I wanted to know, because I've not had genetic testing, although I'm under an inherited diseases clinic in St Thomas's. And I think the reason that I've been told up to now for that is that there isn't anything specific enough about my dilated cardiomyopathy that they were confident about being able to find the genes for it. Although I have heard today that I should be tested now, because I think things have improved enough. I've got 3 children of childbearing age, one of whom is pregnant, and obviously I don't know, they have been tested, you know, they've had echocardiograms, not as recently as they should, but they have had them. So they don't have symptoms, but whether they've got the gene or not, I don't know at this point. My daughter, the eldest one, is pregnant for the 2nd time, so we don't know about her first child. He seems fine at the moment. I know that she was offered some sort of a test, but as she's not been, when she was pregnant last time, but as she's not been genetically tested, would that have been a scan, or what would it have been?
You mean a test for the pregnancy?
Yes.
Okay.
When she was pregnant, they knew that her mother has dilated cardiomyopathy, so they said they'd scan the baby, but I don't know what they were scanning.
Yeah, so sometimes, just as an extra precaution really, they do an extra echo for the baby's heart, just because they know the conditions in the family. If your daughter's heart is normal, the risk to the baby is really low. That's just sort of, but they just do it as an extra precaution. But you're quite right, if there was going to be a genetic test, if you were eligible, the test would be offered to you. And then if we find the gene, which we may or may not, then we would talk about testing for your kids. Yeah.
I think this probably comes under you've probably answered this question already, I missed it, but who's entitled to be tested? I've got 3 children, I've got 2 grandchildren and 1 other grandchild on the way. As far as I'm aware, they don't talk to me an awful lot. I have had a very simple genetic test about 10 years ago and nothing since. Annual scans, when I can rest them from the National Health Service, and the children about once every 3 years. But as far as I'm aware, those are scans. Are they entitled to genetic testing? Question mark.
So if you've had a genetic test and they didn't find the cause back then, when it was done, I would talk to your... Yeah, so 10 years ago, what I'd do is I'd talk to your doctor and see, is there a more up-to-date test they can do? Because for certain cardiomyopathies, there's new genes that have been discovered that wouldn't have been looked at then. So, but they'd need to start by testing you rather than your kids.
So let's say I've got an altered gene.
Yeah.
Does that therefore mean that my children would be entitled to test?
Yeah, if they find the gene in you, then they could offer the test to your kids. They've got to start with you. Yeah.
Hiya. Probably about 5 or 6 years ago, my husband did have some tests, and I think they tested specifically for the Lamin, or as they called it, the sudden death gene. Is that correct?
Yeah.
And he didn't have that, which was great, because I think they were worried because he had atrial fibrillation as well when they discovered it. Are there, and we've sort of left it there, to be honest, because once you knew that wasn't there, it didn't really affect the treatment. Are there other genes like Lamin, because this was about 5 or 6 years ago, that we need to be aware of that of a severe risk issues that perhaps we should be asking? Because our daughter's under Great Ormond Street just for the scanning, and they have mentioned about it, and we just really didn't know, because as you say, it's very difficult. Do you want to know this? Do you not? I mean, we want to know about the dangerous things, but the other things maybe not. Are there other more dangerous ones that we should be asking about now, basically?
Just to check, does your husband have dilated
Yes.
Yeah. So the answer is yes. So since Lamin was one of the first genes that was discovered, but we've discovered a lot more genes associated with dilated cardiomyopathy. We test for 43 now, rather than just the 1. And there is a handful of those that are what we would consider risky genes. So if someone has a problem with that gene, they might be more inclined to give them a defibrillator, for example. So, I would say if that's something that you want to get checked, definitely he should discuss that with his doctor, because there may very well be an up-to-date test for him now. Yeah.
Get my steps in.
Yeah.
Sorry. Hi, I'm Charlotte. I wanted to just share our journey, because I'm also a peer telephone support for the charity. So just outside of this, if anyone has any questions about the journey, then I can share what happened to us. I had restrictive cardiomyopathy. No one else in my family had it. No one had ever heard of it. They tested both my parents, and my dad carries a HoCM gene in 20% of his cells. He has, I can't remember the name of it now, but his cells don't duplicate the same as everybody else's. Mosaicism, that's it. So he doesn't have cardiomyopathy. No one else does, just me. But I guess I feel empowered that I know what my gene is, because I do want to have children one day. And we have options. Like, it's not that I just have to wait and see whether they develop what I developed. So yeah, I think that's like one of the positive sides to it. We got the talk of, do you want to know? You might open up a can of worms. But I now know what I have, so I can decide what I would like to do in the future.
Thanks for sharing. That's I didn't even cover that today. Mosaicism, genetics is never straightforward, but yeah. But I like to hear that it was useful for you to get that information, so you have some choices. Yeah.
What difference to outcomes does it make having genetic tests rather than just having physical monitoring of somebody who's asymptomatic?
You mean for relatives?
Yes.
Okay. So to be honest, not much, because if someone has the gene but they don't have the heart condition, we don't do anything at that point. There's no medication we can give them. We sometimes, depending on the type of cardiomyopathy, we might sort of advise against athletic level training and things like that, certain careers that they might want to avoid. But apart from that, there's not much. They'll still just stay under regular heart scans. Things may be different in the future as treatments develop, but it doesn't change much at this point. It shows them whether they need to continue with that in the future. Yeah.
Very basic question. I've got the condition. How do I go about getting tested?
You're under a cardiologist?
Yes.
Yeah, so I would, next time you have your appointment, I would say discuss it with them. So either them, if they have testing under the service, then they can request it for you if you're eligible. If not, they can refer you either to genetics or to inherited cardiac conditions specialist service. Yeah, but the National Genomic Test Directory, which anyone can access on the internet, has the eligibility criteria. But it's a bit scientific, so your doctor can look at that if you want to assess, yeah.
Can I ask a question?
Yeah, go ahead.
So you mentioned, I'll get it right, hold on, the PGD test, and you said that if that was to be successful for anybody, they would get one opportunity. So does that mean they only get one opportunity for one baby, or do they take a couple of eggs and freeze them for another round?
Yes, so the NHS will fund one baby, which is quite controversial. They will fund one baby, and if you already have a baby that you've conceived outside of PGD and that baby doesn't have cardiomyopathy, you will not be eligible for funding. However, if you go into PGD and you have a cycle and that's successful and there's remaining embryos, you can then pay for them to be implanted, which is much less than paying for the whole process. So yeah, that's how it's working at the moment. I think there's a lot of talks about reviewing the eligibility criteria and things like that, but that's how it stands currently.
Hi, me again. You said LVNC is really difficult to diagnose, like with genetics. Can we just be looked at genetically for the cardiomyopathy, the dilated, just go down that route?
Yeah, so when they do the test, they look at, there's a lot of crossover between the genes that cause dilated cardiomyopathy and non-compaction cardiomyopathy. But if someone just has non-compaction on its own without the dilated ventricle, it's just we don't know all the genes that cause that. So if we do the test, it's quite a low pickup rate, essentially, from it.
Okay.
Good question, though.
Hi. I have dilated cardiomyopathy, and I have a son who is now 27, and he has been diagnosed as having the condition not highly symptomatic, but has been diagnosed through the normal means. And I also have a daughter who is regularly being screened for this condition. At this point, although I've had a genetic testing, I haven't had a definitive response as to, we found the gene that causes your problem. They found possible genes, as you were referring to earlier. So I just want to kind of respond to this gentleman, because I would be very pleased if they found out which gene is causing, or could be the cause of my dilated cardiomyopathy, because we could then eliminate my daughter, who is currently not being diagnosed. And that, for me, is the most important part about the genetic testing.
Yeah.
Apart from, of course, possible treatments in the future, which may be possibly more targeted once they know the genetic cause of my condition and my son's condition.
Yeah, that's a really good point. So when we do predictive testing, although it doesn't, if you have the faulty gene, it doesn't change much except we continue to screen. If you don't have it, we discharge you. So as you say, that's the main reason we do it at the moment. It's really important. We don't want to keep people under screening if they don't need to be.
Thank you. I had HoCM, and my cardiologist didn't refer me for genetic testing, but she said that my boys should have it. They're 35 and 33, and they haven't, but they've been scanned and things. And my younger son is under St. Thomas's, having further tests because they found something. But it should be me first. Is that the point?
Yeah, I don't know if it's sometimes the doctors get a bit muddled, or it might be the wording. So they call it, sometimes it's labelled genetic testing, but it's just cardiac screening they're talking about. Yeah. But if we're doing a genetic test, we have to start in the person who has the condition. We don't just test people because we've seen how hard it is to find the gene in the person that has the condition. And that's why we have to start there before testing anyone else. So no, that's a really good question.
It does seem logical. Yeah. Okay, so I need to push for...
They're
procreating, so
I need to... The test would be for you first, yeah.
Okay, I think we've come to that time. Oh, have we got time for one more question? Sorry.
Hi, nice presentation, and thank you for the explanation of the genetics. I have HoCM, and I've been tested for the gene, a gene, but nothing was found from the panel about 4 years ago. Mm-hmm. What is the interval at which point it's worth requesting for that to be retested, and what's the mechanism? I was tested at the Brompton, by the way.
So 4 years ago, HoCM, we probably don't have much else. It really depends on our developments. Just check in with us. We're happy to check for you. But particularly for HoCM, it's dilated cardiomyopathy. There's been a real boom in finding genes, but not so much for HoCM. So probably come back to us next time you're in, but we might not have much yet. Good question, though.
Well, thank you, Ellie. That's been really informative. I've certainly taken a lot from it today. Can we please just thank Ellie for her time?